Well, on to the next section, 5.2, sum and difference formulas. Before we get on to that, just real quick, take a look at the homework paper. So this is when we were halfway done with the semester, section 5.1, and now we're over here. So as you can see, we're getting close to exam number 2. With the current situation, obviously, exam number 2 is going to be a take-home exam. So when the time comes, I will email that to you, and then you print it out, do your work as if it was a regular test, and then you email it to me by the due date. So we still have a little ways to go, but when we get closer to that, I'll tell you the exact date for that. Okay, then on to section 5.2. So section 5.2 has sum and difference formulas. So what it's talking about is, I want to change this to degrees for this example. What it's talking about is if you have sine of, and now just pick two of your favorite numbers, 12 plus 36. Then how much is that? Okay, it equals 0.743. Well, is that the same as doing sine of 12 and then plus sine of 36? In other words, can you just distribute sine across this plus sign? And the answer is no, those are not the same. So we need to use the sum and difference formulas. So for the sum, and I'm going to start with sine. Sine of a plus b. Well, believe it or not, what you need to do is take sine of one angle, A, and take cosine of the other one, B. And then if this is a plus, this is going to be a plus. And later when this is a minus, then this is going to be a minus. So you take sine of one of them, cosine of the other, and then you switch. Take sine of the B and cosine of the A. Now, when it's sine of A minus B, it's going to look exactly the same, except this is going to be a minus right here. So it'll be sine of the A, cosine of the B, sine of the B, cosine of the A. And I remember it as sine keeps the sign the same. So this stays the same. Now these formulas right here, we're going to use them to develop other formulas, but they do not need to be added to your 3x5 card. Of course, I'm just showing you a 3x5 card while telling you don't need to. That's because that's my little prop off to the side, which then makes me look really smart, as if I remember every formula there ever was. So you do not have to memorize these, although they're going to lead to some very important formulas that we're going to use quite a bit. All right, on to the cosine of a plus b. So with cosine, what it does is it takes cosine of each one, cosine of a, cosine of b. And then it switches the sign. Since this one said plus, this one's going to be minus. And now you take sine of the A and also sine of the B. Last, what if it's cosine of A minus? So it's going to be the same, cosine A, cosine B. But if this is a minus, this is a plus. And then sine A, sine B. All right, now we're going to actually use those in several different ways. For example, number 1, verify this identity. So this is an identity that we used before, but I just showed you an example of it, and I showed you why it's true using a triangle. And now we've got a different way to do it. Verify that sine of theta equals cosine of 90 minus the angle. So what I'll do is I'll start with this side and I'll use this formula. So this is going to be the A, and theta is going to replace the B. So cosine of 90 minus theta. So this is the 90 and this is the theta. So it'll be cosine of 90 and then cosine of theta. And then because this is a minus, this changed to plus. Then it's going to be sine of the 90 and sine of the theta. Sine of the 90, sine of the theta. And technically I'm supposed to put little degrees right here on all of these. Now, how much is cosine of 90? How much is sine of 90? So the calculator is still on degrees, good. Cosine of 90 is a 0. So that means that this part is 0 times something, so that's 0. And sine of 90 is equal to a 1, so this is 1 times sine of theta. And when you simplify that, it equals just sine of theta, which is exactly what that was saying we would get as our answer, which means we're finished. Number 1 is done. Then on to number 2. So for number 2, find the exact value. And whenever we had problems like this before, it always boiled down to either being the 45-45-90 triangle or 30-60-90. Now we can be more creative. Find the exact value of cosine 7 pi over 12. So finding the exact value means don't use a calculator. And in fact, we are going to end up using the 30-60-90. Oh, I made that too small. Redo. 30-60-90. So this side would be 1, this is 2, and this is square root of 3. Or perhaps we will end up using the 45-45-90. Which is 1, 1, and square root of 2. Now this is 7 pi over 12, which seems that it has absolutely nothing to do with 30-60-90, or 45-45. But let's change these to radians. So 30 degrees, if you change that to radians, that's going to be pi over 180. And then that reduces to be pi over 6. 60 degrees, when you convert that one, so this divides into that 3 times, it's going to be pi over 3. And for 45 degrees, that reduces to be pi over 4. Okay, so this 7 pi over 12, for one thing, is probably an a plus a b or an a minus a b. So from this list, is it possible that we could add 2 of those together and get 7 pi over 12? Or subtract 2 of them and get 7 pi over 12? Although I think it's going to be adding them together. So let's see. If, for example, I took these last 2, so this is 1/3, and this is 1/4. So what if we added those together? So 1/3 plus 1/4 as a fraction just happens to be 7/12. So in other words, so on this part I just left off the pi part. So in other words, pi over 3 plus pi over 4 will equal 7 pi over 12. So that's what we should use. Or a slightly different way to look at it is 7 comes from 4 plus 3. So I could do 4 pi over 12 plus 3 pi over 12. And that way they have the common denominator, 12. You add those together, that's 7 pi. So that's another way to look at it. And then when you reduce, this one reduces to be pi over 3. And this one reduces to be pi over 4. So that's just a slightly different way to do this work that I did right there. Okay, now we use this formula. So that means we need to do cosine of each one and then minus sine of each one. So this is equal to cosine of each one, pi over 3, cosine of pi over 4. And because this has plus, next I use minus. And then do sine of pi over 3 and sine of pi over 4. So let's see, pi over 3, that came from 60 degrees. So if you're using 60 degrees or pi over 3, cosine would be adjacent over hypotenuse. That would be 1 over 2. Next, on to pi over 4, that came from 45 degrees. So if we're using 45 degrees, cosine would be adjacent over hypotenuse. So that's 1 over a radical 2. And now it's sine's turn. So pi over 3, that's again coming from 60 degrees. And sine would be opposite over hypotenuse. So square root of 3 over 2. And then finally pi over 4, that one is 45 degrees. So sine of 45 degrees would be opposite over hypotenuse. So that's 1 over the square root of 2. And then they already have a common denominator, 2 square root of 2. For the numerator, this would be 1 and then minus a radical 3. And that is the exact answer. All right, then on to another verify. Example number 3, verify this trig identity, that cosine of 2x is equal to cosine squared minus sine squared. And believe it or not, I'm going to start with the left side. So cosine of 2x. And knowing that I need to use one of these formulas, I think I'm going to use this one right here and just have this be x plus x. So cosine of 2x is the same thing as cosine of x plus x. That's this part, x plus x. And now substitute an x here and here and here and here. So then that's going to be cosine of the first x and then cosine of the second x minus sine of the first x and sine of the second x. And then this is cosine times cosine, so that's cosine squared. And this one is sine times sine, so that's sine squared. And that's exactly what we were supposed to get, so this one deserves a check mark. Then for example number 4, this one is talking about graphing. Find the phase shift So phase shift is something like when you have 2 and then x minus pi over 3 or something like that, then this is the phase shift. So this would be pi over 3 to the right. It got shifted to the right. Now, I'm not saying that's what the answer is because I haven't even written the question, but I'm just pointing out, reminding you that's what phase shift means. And then this one is y equals sine of x times cosine pi over 6 minus cosine of x times sine pi over 6. So what does this one look like? It looks like this one. It's got sine then cosine, it's got minus, and then it's got cosine and sine, although they're switched, but with multiplication you can switch the order, so that's really the same. So that means it came from this one right here, sine of a minus b. So using that identity, this is equal to sine of a minus b, but in here it's not a and b, it's x and pi over 6. And so that means that this got shifted pi over 6 to the right, and that is the phase shift. All right, so that's number 4. Then, for example number 5, find cosine of a plus b. And then here's what's known. Cosine of a equals 8 over 17. And cosine of b is equal to 3/5. It's helpful having this little 3x5 card. So find cosine of a plus b. So that's this one. So we need to know what's cosine of a. We've got that, 8 over 17. What's cosine of b? We've got that, 3/5. What's sine of a? We don't got that. And what's sine of b? We don't got that. So we need to get the sines. So first of all, what I'm going to do is, this one means that somewhere out there there's a right triangle. This is going to be angle A, and cosine is adjacent over hypotenuse. And then we need to solve for this missing side right here, so I'll call it x. So then do the Pythagorean theorem. X squared plus 8 squared equals 17 squared. And then that's going to be 64, and 17 squared is a 289. And so x squared is going to be whatever 289 minus 64 is. So minus 64, that is a 225. So x squared equals 225, and then take the square root of both sides. Take the square root of 225, that's a 15. So this one, x is a 15. And then do the same thing on this side. So there's another right triangle. This angle is B, and cosine is adjacent over hypotenuse. And then because this is a 3 and a 5, this must be a 4. Or if you do the same work as this, then you'll find out that this side is 4. Okay, so now we need to know, what does sine equal? So sine of B, sine is opposite over hypotenuse. So that's 4/5. And for this one, sine of A equals opposite over hypotenuse, so that's x over 17, or in other words, it's 15 over 17. So now we have the missing parts. Back to the 3x5 card. Find cosine of A plus B. So cosine of a plus b is equal to, so multiply the two cosines, cosine of a and cosine of b. 8/17 times 3/5. And because this is a plus, we now use a minus. And then multiply the two signs. Sine of a is 15/17, and sine of b is 4/5. So this 5 times 17, that's 105. So this is 24/105 minus, and then this would be 60/105. And so I believe that's going to be -36. Okay, I better use a calculator. So I think it's -36/105. I'm going to be a little bit embarrassed if that's not right. So I'm going to go back even to here and use the calculator. So 8/17 times 3/5 minus 15/17 and 4/5. And tell the calculator, make that into a fraction. Oh, the denominator is 85. Okay, let me adjust that. This was supposed to be 85. So the final answer is -36/85. You know, in my past life, I would have redone the whole video if I made a mistake like that. But these days, with 5 classes that I have to move to online, I don't have time to redo that. Sorry. And then one more. Let's see, there must be example 6. So another verify the identity. Verify that sine of 2x is equal to 2 times sine of x times cosine of x. And like one that we did earlier, I'm going to rewrite this as x plus x. So sine of 2x can be rewritten as sine of x plus x. And then straight from my memory cells, I remember that it's going to be sine of each one, or excuse me, sine of the first one and cosine, and then sine of the second one, cosine of the first one. So that's going to be, since both of these are x's, both of these are going to be x's. So it'll be sine of x, cosine of x, and then it's got plus sine of x, cosine of x. And then these are the same. Sine of x, cosine of x, sine of x, cosine of x. Since you're adding them together, it means there's 2 of them that have sine of x, cosine of x. And that's exactly what we were supposed to get. So it's finished. And speaking of finished, we're now finished with section 5.2.